More swearing.
Great. So hello, everybody. Happy May 24th. This is our second Zoom meeting that we're doing. This is our first noontime, lunchtime meeting. If you guys have food, brown bag it, feel great. I'm going to let Dean, since you're the one who set this up, and you know Andy, I'm going to let you take it away and let you introduce and do whatever you need to do.
All right. Yeah. Welcome, everyone. We are looking for speakers for future meetups. So if you've got something fun to talk about, please let us know. It could be lunchtime like this one, or in the evenings. Andy's joining us from Belgium. That's why we're meeting, at a reasonable time for him today, but also a good time for us when taking a midday break. Yeah, I've known Andy, gosh, what has it been, 5 years, 6 years maybe, just data engineering conferences and stuff like the notebook environments you were working on at one point. I think that might have been when we first met. But yeah, he's been doing a lot of cool stuff at Kensu.io, the company he co-founded, around various aspects of data engineering, in particular lately data observability. So I thought it'd be great to get his take on what that means and how it applies to the rest of us. So thanks again, Andy, for coming. And oh, by the way, if you have questions, I guess you can just put them in the chat, and maybe even come off mute if you just want to ask something quickly live. But we'll take questions at the end as well. So take it away, Andy. Thanks again.
Thanks a lot. Thanks a lot, Dean. Thank everyone for having me. And indeed, for the questions, you can raise your hand. I mean, you have to have the camera on, of course, for this. Otherwise, I won't see you. But don't hesitate to interrupt me anytime if you want me to drill into a few concepts that I may not have been clear about. So yeah, it's evening time here, but it's a pleasure. So thanks for joining during lunchtime. So I hope you're not too hungry. Otherwise, feel free to take some food. I'm totally used to this, since COVID, we're used to everything. So I'm going to share my desktop so you can see my slides. Hopefully, yeah. Can you see them?
Looks good.
Okay, good. So if I enter the slideshow, I'm checking if I can still see the chat, because I think that I will open the chat too. So I see in case any of you is asking anything. Otherwise, Dean, don't hesitate to interrupt me if there is a question. So I'll take it. All right, so trying to squeeze the things. There we go. Okay. You made an intro about me, so I don't know if I still have to do it, but I'll do maybe real quick. I started my my career after my master's in math and computer science as a geospatial engineer, a software engineer, data engineer, whatever we call it, right? So in geospatial, at least, playing with satellite images and stuff like this, mainly in Java. But at the same time, because I was also a kind of data miner, I was using Fortran and then Python and then a little bit on R. Eventually, I ended up using Scala even for those manipulations of geospatial images and stuff. And this is where I discovered a bit more Scala and distributed computing. Well, distributed computing in different way, right? So using Hadoop, MapReduce, and then eventually Spark across my path. And for the next 5 years, I've been involved in my time quite a lot in Spark and visualization. So this is where I met with Dean in different conferences, one that we gave together in New York, I remember too. And I created this thing, the Spark notebook, which was kind of Jupyter for Scala and Spark back then. But as Dean said, the last 5 years I've been focusing my time on building solutions for let's say data engineers principally and data scientists, but really focusing on engineering side to bring the best practices that I've been using in software engineering into the data world. Also been authoring quite a few books, especially for O'Reilly. And at the moment, I'm writing the fundamentals of data observability for O'Reilly. It's quite a lot of work. I'm still trying to finish the second chapter, but I hope that the first chapter will be out to in a early release, a month or maybe 6 weeks. So please stay tuned. If you want more update on this, I can of course provide. So enough about me. So I will just picture really quickly what a data team can suffer while it's growing, or while a company is growing the data team, because, well, there is more and more enthusiasm about data, more and more interest in bringing value with it, right? So if we consider, the embryo of a data team, we have one guy creating an application, connecting data together, right? It's connecting to the ERP, to the data lake, and or the data warehouse, in this order or not, right? But basically, there is an application that is actually being created by this person that does this with a few connections. So far, so good. We can go in prod, so we have pretty much everything under control. Then everything works super well, right? So we have more and more projects that we have to create, and more and more users and stakeholders. So we grow team, more and more applications are being created, and therefore more connections between the data, or the data sources at least, are being created. Over time, projects continue to grow. So the same person has delivered the first project, the second, the third, etc., etc. That means that the number of let's say the ecosystem that is under control is growing. And as you can see, I always focus on the application, because these are the things that are being created by the people. And over time, of course, because the ERP is not enough, we start ingesting or using more and more different sources from the operational systems. And very quickly, thanks to DevOps, systems and automation and everything, we can end up in a situation where we have already quite a bit of connections between the different sources in the system. And we have to take into consideration a data team, not only the people producing, let's say, data lake or data warehouse data, but also the consumers, right? And the consumers can be another data engineer, it can be a data scientist, of course, but essentially there is a kind of pattern that is introduced, which is, okay, I need this kind of data, and the producer is actually providing a service, which is the data, right, in the data lake or the data warehouse. But basically, it's like request and service, because you need to fulfill a request. So I'm going quick, because then you have these people also creating the report, machine learning, analysis, whatever they have in mind, all their data set in the data lake or whatever you have in mind. But basically, the connection is just expanding to a number which is becoming quite frustrating to keep in mind and to handle. So this is a situation, and even there, right? So it's simpler than the reality, right? Because otherwise the graph is becoming unreadable. But this is, what happens ultimately everywhere, right? So we have so many connections, many applications being deployed, and we have human behind them. And at some point, the data look weird, right? So, or it seems to look weird, right? So the data lake maybe seems to be quite odd, maybe too old, too little, maybe the schema has changed or whatever, but it seems not what was expected, right? And it can impact plenty of people, of course, consuming the data, or through the different applications that are deployed, can impact the people that were developing these different applications at the worst time ever, which is when they are not actually taking a look at them, right? So basically the application are running and the wrong data or weird data is coming into the platform, into the applications, and create some troubles. And of course, the data can come from different places at a point that we don't even know who we can contact actually to understand or to analyze the situation, why the data look weird. You see that actually I'm talking about looking weird because there is also a sense of how to say, almost fuzziness, right? So we cannot really exactly say if the data is right or wrong. It's just like it looks weird most of the time. The thing is that because there is no real responsible, it's hard to find a responsible, or should we actually find a responsible? There is this kind of request service that is kind of broken, and you don't know exactly who can call to analyze the situation, because no one wants to really take a look at the data lake, because if you start looking at the data lake, or the specific data set, you become responsible for it, right? And you don't even know what it means to become responsible for even a folder of data. So too many things can happen. Thing is that this kind of situation is becoming awkward, right? And the whole team is like looking at each other. They don't even know what to do, or they don't want to do what they have in mind they should be doing, right? Because it's too cumbersome, or they have other things more interesting to do. And I've been there, I don't know, 100 times, right? So there is a priori nothing wrong, but it's just that we don't know exactly how we can solve the situation and avoid the situation. Recently, I created this meme that, I'm a little bit proud of it. I like it, at least, right? So basically, how a data team feels like when actually you deploy the first pipeline, you're the superhero, you use all the different technologies in order to accelerate, Spark deployment, Pandas code, whatever, right? SQL can be scheduled and operated pretty easily. But then, of course, troubleshooting has to happen because some issues are being reported by the users, and you feel like the heroes, but they look bad too, right? So from the external, they look bad. And then you have to explain why it happened, that you have to debug, the data, right? But you don't really debug data, though. You debug applications in pipeline for a long period, and at the same time, the stakeholders are not capable, or they don't have the data in hands to work. And of course, because there is issues that are being continually reported, because more and more projects are becoming, are going into production, more issues are appearing, right? Quick parenthesis, so there is a pretty nice paper from Google, which is data cascades in high-stake AI applications or projects, which state that there is a likelihood of 92% for each project to face one issue, right? That means that with 3 projects, you have 100 chances to have at least one of them to have an issue, which is interesting as a number. Then actually you have more and more data issues being reported, and you feel like a toy, until to a point where anxiety can start, appearing when you deploy new pipelines. It's pretty much like when we deploy an application, if we have nothing to actually making sure that the application is running fine, anxiety is coming ultimately. So, okay, so this is basically the situation, but the few questions that I have crossed myself, but I'm happy to hear others, right? Because these are only examples that are actually created the mess. Creating the mess is, the question is, who is responsible, right? Or the users, let's say, I don't know, the marketing person, right? Ask us, herself or himself, why am I the person discovering an issue, right? So I'm not the data person, right? To be in a way. So why am I discovering that there is a awkward number of emails, for instance, right? And the other side, because this person doesn't know exactly who to address the question, right? The other person says, okay, but why am I the person being summoned in the meeting where I have to answer plenty of questions about data I have no idea about? So this is kind of weird situation, but also when there is an issue with the data, an issue between codes, right? So it's always like in the wrong moment. That means that the person who wants to use the data figure out that there is some problem with the data, right? So basically they are already upset. They come to the person who they feel produce the data and just ask, okay, please, fix the data, it's not good. But there is not a lot of information about why the data seems to be good or bad, because most of the knowledge is in the people's brain, not somewhere that can be reviewed by the people afterwards. Other questions like, I'm the data engineer and I have this person that tells me the data is not right. Actually, I'm becoming a little bit suspicious, like, okay, is this person using the data properly and the data is right, but they think that the data is not right? So this is the kind of question that you try to back up a correct defense because you feel aggressed. And also, even is this an issue right? There is so many things happening, applications, data being connected to each other, etc., that you don't know exactly where the problem can come from, right? Is an application that has changed the business logic, for instance, that created some issues in the data, or maybe the data itself was wrong initially or has changed over time, so that the business logic might not be good anymore. So these are all questions that come over and over, right? During the time that the data are being created in systems that are operated individually from us and running in production. But the thing is that those things are creating a lot of barriers. Like we lose a lot of time because when the data is not there or accurate, we cannot work. So we cannot we cannot work basically. So we don't have the data to do so. It's a pain. It's a big pain because we have little time to fix the issue. So generally what we do is that we patch. We try to do both some backfilling, we retry the pipeline, or we patch the data at the end. So we do whatever it takes in order to get rid of the issue, to contentate the stakeholders, and then get back to the project that you were working on. So there is no real, I would say, root cause analysis really, or identification of the real issue and trying to fix the issue. Generally, we just patch. Because I just said earlier in the meme, right, basically everything is coming back again, and it creates some anxiety, pretty much like when you push deploy, the application on Friday before going to the weekend, right? It's becoming in a way something like that, because you feel like you don't have the control about what is going on the data later on. So I'm trying to go fast here because I guess most of these things are pretty typical for you guys who are working with data every day, right? But the two things that I think are the source of these issues, right? I would say these kind of situations come from two big aspects, in my opinion, right? First, it comes from the fact that there is little visibility of what is going on with the data and about the data when it's deployed in production. There is almost nothing reporting anything about it, right? About the data. And there is a nice book that explains why it should be important to have this visibility, which is dark data, and why what you don't know matters. Sorry, nice book by David Hand. And the other aspect is, besides the visibility, as there is no consensus about what is a data issue, right? There is no consensus that says this data is right or wrong, right? Because this consensus would happen if everybody has the same perception of the data, right? And to have the same perception of the data, they probably have to use it in the same fashion for the same purpose, which is of course not the case, right? Because they have their own purpose, they have their own way of using the data, they will have a different perception of the quality. There is a nice book called Talking About Quality by Vivek Nanda that says, okay, basically the quality is always something that is subjective. And because it's subjective, how can you come with a consensus about what is good data and what is wrong data? And how, if we consider the fact that it's subjective, how are we going to circumvent that, right? As an engineer deploying pipelines, still that has to be create data that has to be used by many people. So we have to cope with this fact. So these are two big, problems that we have to deal with. And that's where observability comes into play. So basically, in order to understand data observability, or for me to define data observability, I have to talk about observability in general, right? I guess observability is a term that you have already encountered, right? Whatever it is, because you have watched videos about Splunk, or you use Splunk, or Datadog, or Dynatrace, or I don't know, Open Telemetry, or New Relic, whatever, right? So these things are observability, right? My simple definition of data observability is included into observability. So observability is really a capability, right? So it's an ability of the system to generate information about what's happening internally, so that some guy external can understand what's going on internally without having to access the system, right? It's observing, right? So it's capable, this person is capable of modeling, right? So what is the internal state of the system without having to access to it, right? So it's important to not have access to it. Because otherwise it's not an observer. And in order to actually have enough information for a system to be observable, right, there are at least 6 areas that I have regrouped together, right? You can probably come with others, but the 6 main areas that I'm describing here are those. So we have observability about infrastructure, so the servers, machine, everything. So what is happening at this level? Application, so how the applications are being are behaving, security, how is the security applied, etc. User and purpose, who is doing what, what are the reasons these things are done. Analytics, how are the data, so here we come to the data, how are the data being used, transformed, etc. for what purpose. So here we come back to the purpose, and then finally we have the data observability area, which is what we're going to dig in a little bit in the next slide, right? But the thing is that because we want to be able from the outside world, right, using the data coming to us to understand the whole state, right, we cannot analyze it in an independent fashion, right? So we cannot analyze infrastructure independently from application, independently for security, etc. It doesn't make any sense, right? So basically, all these areas are just different facets of the same word, right? And then everything they have cross points, right? That are super important, because then we can create the relationship, that will give us more insights about how the system is behaving. It's pretty much like when we use data, we use multiple features, right, coming from different areas, probably, right? And we have to do the same for understanding how the state of a system is. What is the state of a system? So all these areas actually are encountering the others. They have intersections. So this is why the Venn diagram is the best way for me to represent this. But that means that the data area is crossing all the different others, right? So we cannot conceive data observability without actually mixing it with the other areas of observability. So real quick, right? So this is not, so yeah, sorry. So real quick, so I said that observability is not new, right? So infrastructure, we are logging, we have platform that receive the syslogs, we can have the top, the root and everything in order to receive the logs, some metrics and some traces, right? So I guess that you're all familiar with that, right? So basically we have log, metrics and traces. And we have already used, of course, for quite some time in application like logs. I mean, we've been using logs and stack traces for quite some time now. But open tracing, open telemetry, and these things are becoming more and more standards, I would say, in order to produce both metrics and traces. Traces being either the connections between a component, software component, or even different services that are distributed, right? In security, we have the security logs and traces. That's there for forever, I would say. For user and purpose, we have the capacity to use stuff like audit logs and even, you know, Git blame-ish, right? So when it comes to code, for instance. For analytics and data, this is where, I mean, this is kind of new, right? So we don't have anything that we're using for quite some time in order to get a really understanding during production, right, of the data analytics behavior, right? So we can think about data logs, but data has no real logs, right? Data are just tables, right? So the system that is handling the data can have logs, but the data per se not. We can think about analytics. We could think about SQL logs, right? But SQL is one thing, but there are other stuff that can be considered in order to provide observability for these different areas. So we'll dig into what is necessary for these, at least the data observability area, to create something substantial that can be used to solve the problem of visibility and the subjectiveness of quality. So data observability, actually, so this is why I have to explain my vision of observability, because of data observability is one area, and data observability is there to provide information. So the system has to generate information about how the data can influence the whole system, right? So how a data that used to be, I don't know, 1 terabyte big, right? So at some point it 1 terabyte, and the day after 10 terabytes could influence the system, right? Like blow a Spark application or whatever, right? Or fill the disk like crazy, right? And the other way around, right? So how the system, let's say an application that is deployed with less memory than it used to be, right, can impact how the data is being generated, right? So these are the information that will understand, you know, what is the behavior of the data in a way in this context. In order to, so there are many different information that we can generate, but if we concentrate on the logs, metrics, and traces, right, we can think about these things. And we have to link them with data, right? So we have logs about infrastructure, application, and users that are related to the logs, right? To the data, sorry, like where the data is being stored, what application is using which data, who is the user that is using an application for that uses data, and what is the purpose. You know, these are logs that we can detect and reattach to the data, so that you can face the very first questions like, why am I the person detecting an issue? Why, who do I need to ask about this issue, right? So because we have enough information about the system, we can already answer these questions. Metrics. So I'm talking about data metrics, right? So statistics, it can be anything, right? It can be statistics about a column, right? So let's say the age column into a customer table. You can have the mean, the max, the mean, whatever, descriptive statistics, right? But it can be also the number of nulls, it can be the number of rows, it can be also the skewness of the data, it can be the distribution of the data, it can be different things that represent an information that can help the observer to understanding what the heck is going on with the data in an application, right? So it's not only profiling. Profiling is a little bit different, right? Profiling is something that tells someone, you know, what the data contains in a way, right? So this is used in order to do better exploration. Here, the data matrix we're considering is to create visibility about how the data is behaving, which is different, right? So when it's used, not to be used yet. So, but these are very important in order to understand with this matrix, you can understand why an issue is really an issue, right? Because you know that maybe the minimum age that you were receiving so far was 25, and at some point it bumped up to 40, for instance, right? So this is an information that can be used in order to understand, you know, okay, so this distribution has shifted for whatever reasons. It can also elevate the doubts about an issue, right? So because you see that the data is changing so much, right, that you cannot really confrontate your stakeholders like, okay, are you sure that this is really an issue? No, actually, this is visible from the metrics. That's a good thing with metrics, that they are factual. And finally, the traces. In data, the traces are called data lineage, right? So connection between the data, right? But I would say that data lineage only is not enough, and I will come back to that later. So we need both apps and data lineage, right? So what is the connection between the data applications, right? So let's say the traces then, right? And underneath, you know, how are the data being connected across different applications, right? This is really important because when there is an issue and we have to perform troubleshooting, for instance, we have to understand which application we have to look at and not only the data, right? Because at some point, if we have to fix a data issue, right, we're not going to fix the data directly, right? So we're going to fix an application that is either consuming or producing the data, right? So this is why we have to have this information about the application along the lineage. So in a way, every time I present this, it kind of makes sense, right? It's like trivial, right? But the thing is that they don't exist yet. Most of this information don't really exist, right? So they have to be built, right? They have to be created, they have to be reported, and then we have to use them, right? So how can we do this? How can we make a pipeline data observable, right? So let's imagine that you have this simple pipeline where we have apparently some pandas and dbt. Again, I'm assuming that you are familiar with these things. So let me know if not, right? But basically, you have pandas and then you have dbt, and dbt uses the Spark engine to run some SQL scripts. Let's put it this way, right? And you want to, get rid of this fog, this kind of blurry vision that you have about the pipeline, right? So the way you can do this, pretty much like we would do in application, by logging two things, right? Logging from the application. So what is the behavior, stack trace, null pointer, whatever, right? So we would be logging, and also a measuring, right? So the idea would be, in order to making the data pipeline data observable, right, is not to look at the data themselves, but to keep the focus on the applications instead, right? So where we have control, because we do create application, we don't create data, right? Unless you are a data entry guy, right? We don't create data. So basically, we keep our focus on the applications, right? And then we're going to do the necessary for them to produce the logs about the application themselves, right? So I am a Panda application, a Python application. My name is this, my Git repository is over there, my version is this and that, right? dbt, same thing. So I'm a dbt job, I'm running this kind of SQL, etc. Metadata logs, this is actually interesting because generally the way we conceive the logging of metadata is by reading the data source directly, right? However, because the application connects to the data, consumes and produces it, the application can also produce this metadata, right? And the cool thing is that actually they produce the metadata about the data they are consuming at this moment, right? So that if there is something going fishy with the metadata, maybe some columns is missing, right? You know it from the perspective of the application, because what's important is what the data look like when the application is consuming or producing it, not at a different time, right? So the metadata can also be produced easily by the applications because they have access to the data. Lineage, I mean, what if not an application is creating a lineage, right? A lineage being the connections between input and outputs is creating an application. Therefore, an application can fairly easily, create these logs about, okay, I'm using this and I'm producing that, right? It's much easier than try to take all random logs about transformation or whatsoever and try to reverse engineer what happened in the application from non-lineage dedicated traces, for instance. Right. By the way, this is why we have introduced distributed tracing in the service meshes, right? In order to not come with, ad hoc, non-standardized logs that needs to be regulated afterwards, right? There is some information that is created directly by the application. And finally, computing the metrics, right? So because the data is actually being consumed and produced, right, or accessed and generated by the different applications, this is also a nice time to actually compute a few metrics about what you consume and produce, right? Again, because if there is an issue, you want to understand how the data behaves during the time that the application is actually consuming or producing them, right? Not a different time, otherwise you will be influenced by potentially, inaccurate or outdated information. So the application is where you have the control. So this is where you should apply it, right? And the good thing is that because you have all this information that can be generated at application level, you can even validate your expectations, right? Which is like testing in production somehow, right? Or it's like pre or post conditions. You can generate these logs and metrics and everything, and then you can check, okay, do I have all the different columns I'm expecting? Do I have as much information as I used to have? And at least I have enough information to produce the result afterwards, etc. So these expectations can be checked directly at the application level, again, where we can actually change something, not in the data. So basically, based on this information, we recover some visibility because we know how the data is being connected, by which application, what is the schema of the data, what are the different metrics during the execution of the different codes, and etc. So Actually, visibility is coming for free based on information that could be generated there. Excuse me. I'm going to drink a little bit. I don't know if there is already a question because I'm trying to go fast on purpose because I want to show you something afterwards. I'm actually almost now.
Andy, one quick question. In our experience, about 50% of the problems are because of the bad data. And you don't have data validation in your pipeline. Is it on purpose or you're just hiding it?
Oh, so yes, actually the validation can happen. Look, actually, Mike told me that I can annotate, so I will make use of this. Can I annotate? Oops. To annotate, maybe I have to, come on. Sorry, I'm trying to see if I can annotate.
You have to drop down.
Yeah, but generally there is this. So it's the second time it.
It's under view options.
Yes, but I clicked on it, so I can annotate, apparently, right? But I don't see the small bar that allows me to erase and everything, no? That's weird.
That should pop up, yeah.
You can just say it. Are you assuming that pandas are doing validation before they do any processing? Because this is kind of very important step that people often forget.
Yeah. So this is where actually it can happen, right? So in pandas, because you consume the data or Spark, whatever, right? You have the data at hand, so you can compute statistics or some whatever you have to compute, right? And then you can validate there, right? Because anyway, in the pandas application or whatever you constructed, you have all these assumptions already in your brain when you build them, right? I'm consuming these different columns, I'm consuming so many rows, right? I know that I have this data being connected to this other, etc. So this can be checked over here, right?
Yeah, and this becomes an important piece of the data pipelines that you have to log very, very carefully.
Yes, yes. It's pretty much like when you build an HTTP service, right? And you receive a JSON HTTP request, or an HTTP request with a JSON payload, right? And it's like you process it, whatever there is in the JSON. We don't do that, right? We always check that the JSON is actually a JSON. We check that it contains the value that we need. And then if it doesn't match our expectations, we return an error in the HTTP response, right? Or if it's not, right, then we save it, we use the CRUD or whatever operation we're going to do, etc., right? But we don't do it with data. Why? And we could, right?
That was exactly my point.
Okay, good. So then we align. Whoops. You know what? It's going to save my my drawing then. Okay, cool. So it erased them. Perfect. So that's the idea, right? So basically, and this is when we write code that we have all these assumptions in the brain, right? So we're building them as we code. It's pretty much like when we write the code, right? An application. It's like we write the whole application and then we come back to the application and we add the if and then and else's and the logs and everything. We don't do that either. We write these different checks and the logs as we go, because we already have in our brain at this moment the different corner cases that can happen, right? That needs to be logged, right? Right. If some value can be null, right? Okay, you catch it, right? For instance, right? Right? I don't know if this is actually making sense for you guys. Whoops. Can you hear me? Whoops. Okay.
Yeah, Andy, that was exactly the point that I was trying to make, that data validation is a huge part of observability.
Yeah, yeah. So what I'm calling this actually continuous validation, right? Because when we talk about validation, I often hear about data checks or data tests, right? So you write your pipeline and then you do some data test, right? The thing is, the data tests, okay, so they work during the testing phase, but the data can change anytime, right? So in a way, the test that you do, the different checks that you do during the tests, right, shouldn't be in the test code, right? If you check that, if you need to have, let's say, the address column, the age column, I don't know what, right? And if you do these tests in these checks in the test, I mean, they won't be validated in production, right? So you need to do them in the application code, right? And you can still have data tests in order to make sure that if the data is not there, right, the checks that you do in the application code is failing, right? So basically, you're not creating any, as it's noted here, garbage in, garbage out, right? This is when I created Kensu, this is the one thing that I wanted to fight first, right? Using the garbage in, garbage out excuse, right? Okay, so the data is wrong because I got garbage in, right? But well, yes and no. If I am able to understand why I'm getting garbage in, I won't produce any garbage out, right? But in order to do so, we need to be able to validate it, which is not so easy. I will come back to this too. Here, actually, I'm coming to this here, right? So there is the concept of SLA also, right? The data test, and then there is SLA, right? It's a fancy word, right? In data, right? So service level agreement for data. And again, we hear the term service, right? Because there is this request service between the consumers and producers, no matter what, right? And the thing is that because each consumer may have its own perception of the quality of the data, how do we do, right? Actually, it's not so easy. The idea is that instead of trying to have an SLA that is global for everyone, right? The idea is to have at least a plenty of potential SLIs, right? So you know what SLIs are, right? So service level indicators, right? These may be indicators of the service level. And these indicators can be at least all the different metrics that you can produce. What's interesting here is that if you consider only one table with one column age, you can have so many different SLIs, right? It's minimum, it's maximum, it's mean, it's median, quantiles, whatever, right? Standard deviation, whatever. There are so many different SLIs that can actually be used in order to expose the validity of the data, right? And depending who you are, you may be considering, you know, the shape of the distribution or its range, whatever, right? So the idea is to use at least these SLIs to propose, you know, to your consumers, you know, what are the most important ones, right? So that's interesting, so that there is a common agreement on what are the most important SLIs, KPI then, right? That needs to be ensured during the operation of the pipeline, for instance, right? And you know that if one of them is failing, well, you have to team up in order to face the situation. What's interesting also by producing metrics, right, is that at some point, of course, you can identify all the different SLA or SLOs, right? But having these SLIs, right, and metrics can help discovering new ones that can be introduced later on, right? So it's like, it's not a fixed thing, like it's not something that you define once and then you leave it forever, right? Actually, this is a ongoing discussion, but the good thing is at least it's not non-factual, right? It's really factual. It's based on things that has happened and metrics that have been produced. So there are a few use cases that you can leverage, that you can have based on the information that can be produced there. But also there is some cherries on the cake, right? Because the application are capable of validating the data, generating metrics, metadata, lineage, and everything, they can actually create a plenty of information that can feed the catalogs. You know, these things that we hate documenting, right? We know that it's super important, but we hate them because it's a pain, right? So to go there and to document what we've done, the different tables, the different schema, whatever we've done, potentially the lineage manually, it's a hell, right? So the idea is actually to use information that the application can generate in order to feed those catalogs automatically. The other use case that I encounter very often is a data quality scorecard. So a data quality scorecard is kind of a score that is attached to a data set, right? That gives its trustability in a way, right? Trustworthiness. So in most of the tools that are manual, right? So you use the star thing, right? So the users potentially come there and then they star them, right? But it's like any star system, right? Most of the people who use it is in order to put 1 or 5, right? So it's not really useful, and also it's not always maintained / never maintained. The idea is to generate scorecards by using the fact that you have metrics, validations, SLAs, and then by mixing all together in order to have a compound data quality scorecard that is let's say that can aggregate how often, for instance, the data source is matching the expectations, for instance. So this is actually pretty nice, because then the scorecard is automatically fed and maintained by the logs and the metrics instead of requiring any extra work from the users and even the producers. So there are, of course, there are use cases you can find more and more, and we are only at the beginning, I would say, of data observability based on information like this, right? So I expect that we'll discover over new use cases. Now I wanted to show you something. So what time is it? 51. So I don't know if there is already a few questions before I show you, what it would look like to how we could actually generate these logs and metrics. One, two, no, I pursue.
Yeah, keep going.
Yeah. So basically you can go there too if you want, right? So there is documentation or whatever, right? So no need to maybe to go now if you want, but actually this is free of charge, right? So you can use it, right? So I'm not pushing anything here, but just a method, right? So what I want to show you is Rockadoo, this come on. This pipeline that I've shown here, right? Basically, you're consuming files, producing tables, and then the tables are producing this table and this table. I'm going to run it, right, from a script that is available here in the documentation of the sandbox. It's the marketing use case, but I will run it without Kensu first, without data observability enabled. If this thing can go and let me pick my terminal, there we go. So there is a GitHub account repository where we have created a marketing campaign that is recreating this pandas code, reading files, producing tables, and these tables being used by DBT, producing another table, and this table creating another table, right? So basically, we consume consumer and contact info, and we generate some orders tables at the end, and contact information at the end also. So I am in the Git branch that has no. Wait, I'm going to go to the Git branch that has not any observability in. So DO is disabled, right? And what I have here is I have the pandas code and I have the DBT code, right? So basically, this is my pipeline. I'm going to install it, so you can run it also on your own, right? So basically, I will install it, and install it will just execute a. It will just launch this Docker Compose that is starting first a Postgres table database, right, in Docker. So I have my engine for the SQL relational database and tables, and then I'm going to run the script that is taking these files and generating the tables and the tables to the tables quickly manually. So I will execute it the first and the second executions, right? So I will run the pipeline twice, right? And then I will explain what happens. So basically here I have no data observability. I have my pipeline that run on the, let's say, January data, and then the month later it generates some data from February, right? But it's running like in the background, right? In the meantime, I can connect to my Docker Postgres, right? So bash, I will connect with my Postgres account, and I can go here, and basically I have to connect to the database, which is test.me, right? And here I have two schemas, one that is containing the data. The public schema is containing the data which is created by the pandas code, and then I have the schema which is containing the tables created by dbt, right? So here, if I show you the tables of public, oops, sorry, I have customers and others, but I have also test.me schema, which is the dbt ones, which are containing the orders and customers and contact list. So in the background is running. So these tables have been created, and yeah, the data is generated there. What will happen at some point when it's done, right, is that because the pipeline generate the contact list at the end, right? So I can remove this. So the contact list here, so the contact list I will show you here is containing, so select star from test.me contact list, limit 1. So it contains the first name of a customer and the phone, right? So this is used by the salesperson in order to give quotes, in order to sell new projects and stuff like this, right? So this has been built for this. However, the salesperson is super angry because actually nowadays the last run, right, most of the phones are actually empty in the table that have been created for this purpose, right? So what happens is that super hungry, they come to the person and say, hey, you guy, actually the data is awful, right? Cannot work. Please fix this. And let me know when it's done. So what happens is that in order to understand this, right, what I have to do as a data engineer, I have to connect to the database. So I have to remember, okay, which table, how it's using it, in Tableau, whatever. I have to go to Postgres. I have to connect if I can. Generally, I can, but let's say I can, and do this kind of query and identify that, okay, so this is the table that is actually wrong apparently. And what the person told me is that the number of the phone seems to be empty. So I can count how many of course contact list I have which have their phone nil, right? And then I will see that here I have 185 nil in the phone column. Okay, I'm not sure what exactly that means. That at least I see that there is quite a number, right? And actually there are 386 rows there, so it's quite a lot in a way. So two metrics interesting. So how many null values and how much data I have. But well, okay. So how is this list? How is this contact list being created? Right. Okay. I know that because in my brain, right? So I know that this is an application that is actually a dbt application. I know where the code is. I can go to the code and I can check the code, right? So basically, I can go to example marketing and I can show the models, right? And the models, I can show contact list, right? And here I see that the contact list is created out of the order and customers table, right? So, well, and the SQL is pretty simple, right? So basically we just fetch, it's like a view of the data. So super simple, right? But in order to understand what's going on, I have to go back to the console and I have to check, okay, so what is the current, hopefully, so it's named phone as well. So I can go here and I can ask how many null values I have in this table too. Okay, so apparently I have the same thing, and I'm lucky the name of the column is the same. Cool. So actually the problem is not in the DBT SQL, so it's elsewhere. So it's before. Okay, so from where is this order and info coming from? Because I know that it's in DBT as well, so I know it's there. Again, so it's based a lot of the information that I have in my brain. I see that orders and customer is based on two tables that are being joined, orders and customers, you know, and we join on the ID. Okay, cool. So apparently we have orders and they're coming from a row Postgres, right? So if I look at the schema of DBT, it's easy readable, by the way. Maybe I have to increase the font. Hopefully,
It's not too bad.
Oh, slightly more.
Maybe a little bit, sure.
Okay. So here actually I see that this is coming from the public schema, so I can actually go back here, and maybe here I can also increase it. There we go. And okay, now I have to actually the problem here is that I have two source, right? I don't know exactly where phone comes from. Is it an information that is part of the order? So you know you can be called if the orders is going well, etc. So you provide your phone number, or is it information that comes from customer, right? You're not sure, right? So you have to identify it. So what you're gonna do is that I'm going to select star from let's say order first, right? And I'm limiting one. So this is not the way you get the schema, but this I'm lazy and I'm doing always like this. I'm seeing value, which is not super GDPR compliant, right? But it's easier than going into the schema repository of Postgres, etc., right? But and basically everybody would do this and create some compliance issue, by the way. And here there is no phone information apparently, so I can go to customers and I see that the phone is there. Okay, so what I do again, so and I'm doing some random thing, right? I'm not random, but very simple, you know, queries, right? So nothing super hard, but I have to do them in order to understand what the heck is going on, right? Where phone is null. And indeed, so here we have null values, right? So, okay, so apparently I have null values and apparently it shouldn't be the case, right? So I have to identify how this table is created. Okay, the thing is that, so I'm reaching the end of DBT, right? So now it's in another word, right? In the Python, in this case, or Spark, whatever, the other ingestion phase, let's say. So in order to do so, right? So one way to do this, I would maybe potentially know that, sorry, I can check, sorry, how, oops. So I can check how the second execution is created, and I see that I'm running DBT after the pandas v2. Okay, cool. So in order to know what is pandas v2, I can check this, and I see that we're loading the campaign with a parameter second. Okay. So I can check what's in this file, right? Load campaign. And here I see that okay, so the argument one is used for campaign, and okay, here we read the CSV file, like, okay, so it's campaign plus underscore campaign customer list, so it should be like second underscore campaign. Okay, but probably the problem is also there. So what I can do is I can start another scripts, and then of course, because I'm as good as pandas and I'm good in as in SQL, so which is not super good, by the way, but anyway, import pandas as PD, and then I'm going just to read this data because I don't have access to the server and read the data as I want. So imagine that it has like 10,000 rows. So it's easier to start doing some exploration to understand what the heck is going on with the data, right? And for this, then I have to go to this folder right? Imagine it's in the, excuse me, on the data lake, right? So it's not that simple, right? So we have to connect the, I don't know, the HDFS the jar or whatever needed for the pandas to connect to this. But anyway, let's say it's as simple as this. And then we have a second campaign. And then we have a customer list. Boom. So we have the data frame. The data frame looks like this. I have the phone information. Yeah, whatever I'm doing here is accelerated by a certain number, right? So it's nil and then sum. And here I have also my 69 number, which is the number of nulls that I have in the file. So apparently I have the problem in the files, which is the limit of my knowledge. Eventually, I'm lucky. I know who is actually creating the files for me, right? So I'm calling the person and say, oh, actually, what's going on? There is some null values. I have 69, so I'm providing an information. 69. This is the number of null values that I get, right? What's going on? The person on the other side says, oh, actually, I know. The form that is used to do the orders and the customer registration has demarked the phone number as mandatory because we had a high bounce rate. Right. So we just removed the mandatory field and now we have more people, but they're not providing the phone numbers, but they all actually pretty much provide the email or whatever. Right. Okay. So now I can call after this analysis that eventually took quite some time, right? To get back to my users and say, okay, look, actually, this is what is happening. Well, actually, now you have to use emails instead of phone if you want to increase your numbers and hit your targets. The thing is that, so I haven't done something, super hard or whatever, right? Basically, I wanted to control how many null values I have, not as simple as this. And I took a simple case on purpose, right? And I got some trouble with it because the visibility was not nice, and then I don't know exactly what is null. If null is a problem, how many null value I got in the past. I know what I have today, but I don't know how many I got before, right? So I cannot really assess if 69 is good or bad. Maybe I had already 60 last month, right? But I don't know from the data set, right? All this information are totally unknown for me unless I'm actually scanning or looking at the data often, right? Which is of course not something I want to do because I have other things to do. So the other alternative is to generate directly from the pandas and DBT. So this is what you were, of course, expecting, right? So what I'm going to do now is that I'm going to rerun the same script, but with data observability in now. And I will show you what it takes to do this. And then I promise I'm done. It's 8:07, so I'm almost an hour talking. So I'm going to clean this. Clean Docker, so remove the containers and everything. I'm going to show you the difference between this branch and the branch where DO is enabled, right? And there is not much than this, right? In the Python script that I shown you earlier, where we load the data, right? So we had import pandas SPD, and we changed this into another layer, which is the data observability enabler. So we have an extra layer, which is an open source library that I can show you on GitHub afterwards, which is adding on top of pandas a layer of observability automatically, right? In order to create the matrix, the lineage, information about the application, etc., right? And this is how you initiate the logger, right? It's like any logger, right? So like log4j, oops, no, maybe not this one, but any logger. And everything that is actually used using pandas or NumPy or whatever, right? Because there are plenty of different libraries that were supported in Python, Spark, even Flink and DBT and Airbyte and whatever you have in mind, is actually creating all you need in order to create visibility. So now I'm going to check out this branch, enable, right? And I'm going to do the same, but I'm going to first connect to the platform. So I'm going to the sandbox that you can connect to, right? So you just need a Google account, right? I'm connecting quick. All right. Okay, so I'm landing here. So in order to configure my logger, right? So I need to provide the token to publish information directly to the platform. So it's my account is this one. So this is the one. So here I'm copying some DWT token, right, to connect to the platform. So I'm going to configure both DBT and the Python script from the configuration file by providing the data observability token, right, that will allow the observation to be published. And I need also this thing. So actually, you can install Slack on it in order to receive what I will show later on, alerts directly in Slack. So when there is an issue, you can be notified right away in Slack. But there is also connectors for Jira and everything, by the way. So here I've configured everything, so I can install it again, right? Just starting a Postgres as I shown you earlier, and then I can start my script again, and we'll see what happens, right? So what I will get, right? So what I'm expecting is that I will have visibility about how the data is being produced, consumed, and how I will be able to process it, right? In the sandbox, which is a version a little bit limited of our application, right? You will be able to actually review all the different data sources that are known by the system, including, the test me public customer, for instance, and the test me orders, which are the two tables being created by the pandas code, right? And when DBT will have run, then we will see the test me schema, orders, and the customers, and then actually the customers. But for this, we need to leave DBT running. What happens is that when it's running, right, when the DBT code is running, so DBT, in order to execute the SQL that I shown you earlier, is using Spark as the engine, right? So what has been done is that the Spark engine in the DBT runner has been updated to automatic log data observability information, so observation then, right? So like schema, sources, lineage, whatever, statistics, whatever you have in mind. So DBT has been upstepped in order to generate automatically data observation. So, and here you see that I have my orders and customers, and I have my contact that has been created, right? So this is my data sources, right? If I show this, I see this is a Postgres table. I know its location, right? And if I click on it, right, I know exactly. So I know this is a Postgres table, and I scroll a little bit to show you first the lineage, right? So I know that this table comes from public orders and public customers. And the public orders comes from orders CSV. Likewise, the customer, and they are joined into this table here. And by the way, the test me customers is actually being used also to build this outcome. Actually, because I zoomed, I don't see it correctly, but here, this is the contact info table, right? So I see directly, how the data are being connected across applications, right? And I can filter by application, by the way, because I know how these lineage are being executed and created, right? So if I click on Python data load, right, I will see that this pandas code is actually reading CSV and creating sources, right? If I look at the DBT, it's only consuming those, right? So what's interesting is that you can have visibility about how the data is being produced and consumed. But not only, right? So this is interesting, but not only this can be produced, right? I'm going to refresh real quick, right? In order to have all information available. This is the schema. First, I can show you the schema of this table, right? Because the application have been reporting, what is the schema of the table, right? So I know exactly what are those fields, including phone is here. And we see here that phone has been used into another query. The others have not. So this is interesting information. What are the fields that are used and unused, right? And also this is information that can be observed, right? And in terms of observation and metrics, so to speak, I can select let's say the phone information, I will get automatically the number of levels, so how many unique values I have, and the number of null rows, which is automatically computed, right? And here I will get this information, which tells me for the phone information, I have 50 unique values, and I have a plenty of null rows, which I haven't in the first execution, right? I see a bump in the number of null rows for the phone, which is not appearing in the other. So here I clicked on missing values to show all the missing values of all fields, right? I can see that, okay, emails have a slightly bump into the null information, because in the form they also put emails and non-mandatory, but it's more likely filled than the others, right? Still, so we still have only 14% of null values, but actually now we have 48% almost of null values for the phone, right? So this is a huge bump. And this can be actually seen in the table that is consumed by my sales, right? I can go to the table here, the sales table, which contains the phone and the first name, that comes from customer along these applications. And here, if I show the missing values, I will see that a ticket has been generated because there are too many null values for the phone. So because we can observe how many null values we have, right? And I knew that the number of null values now, because the sales already put me on that, right, is important, right? I have a rule that is validating automatically that during the execution of the DBT thingy, right, that is validating the number of rows is not greater than 0, right? So now it becomes super important. There is an alert that has been sent to Slack, that has been sent to Jira, that is actually telling you directly that there is an issue. And then you can do the analysis, as I said, by browsing simply, the different applications and sources by clicking here, instead of going on the console, going in the code, going in DBT, going in different places. So that's the purpose of observability, having really everything in one place with all information that is linking everything to each other to ensure that you have the right visibility to understand why there is a quality issue for a specific use case, right? In this case, the use case is the DBT contact list, not everything, because there are plenty of applications that don't give a dime to the null values in the phones, of course, and those are not interested in that, so you don't actually notify them that the null values are increasing in the phone table column, sorry. So basically, everything is at hand, so I can actually browse and browse and browse, but the intent is not to show the application, but more, how you would perform the root cause by scanning again till there. Very quickly, you can go there and you can see that the CSV file, so this is the CSV file, right, has missing values for the phones, 69 here. So you know that you have to call the person on the other side of the building who's generating the CSV to ask, okay, what's going on here? So no queries, no access, no pandas to perform any CSV operations. Everything is at hand. So that's the intent of observability, and what I think is mandatory for any data engineer to conceptualize and to introduce, in their philosophy and best practices, so to speak, generating logs, metrics, and traces. I hope it makes sense. And you liked it, even if we lose a few people along the way, which is cool, right?
Yeah, any questions? This is pretty cool. It's really interesting to see what you guys have been doing here. Sure. I noticed a few people dropped at the top of the hour, probably because we had meetings, the usual thing.
Hey, I did have one quick question. I've seen another tool out there called Big Eye that does a lot of discussion around observability and sort of using AI to set boundaries around some of the logs that are captured. How would you sort of compare that tool to what you're trying to accomplish here? Is it sort of fit in the same stack? Is it different in some way? Just curious.
Yeah. So what happens there is it's using CDC mainly, right?
Yeah.
But CDC, so there are two things, right? First, CDC explains how the data changes, not that it's consumed, right? So you don't have any information about how the data is being consumed and what are the potential representation of the quality issues that the consumers may have. You just know how the data is changing, right? So there is a big gap here because always the quality is referring to how the people are perceiving the data and using it, right? So that's a huge gap, I would say. So using CDC to get some information about the data, right? It's pretty much like scanning the data, right? You scan the data and hopefully you create, let's say, a broad quality statement about the data. So this is one, right? So basically you cannot identify, which application may see an error because of the data. Second, the CDC doesn't tell which application has changed the data, right? So you cannot easily identify where the heck you have to change, in order to reestablish the situation. You still have to do the heavy lifting to understand, okay, so I have the data that has changed, maybe because there is a Java application that is sending the wrong data and not the Python one this time, right? Or maybe there was my data application migration, right? So many things can happen, right? And you don't have this information, only the log of the database, of course, right? Only the application knows. So this is second. The other one that I have in mind is come on, so there is no lineage either, right?
Yeah.
I have a list of things, right? Because
Right.
I've been working on scanning the data, right, for 20 years, right? Oh, we need data quality. Okay, let's scan the data. Well, I mean, this is not how it works, right? It's like, okay, I need to have car quality. I'm going to scan the data when they're actually being driven, right? This is not how it works, right? So these are the different concepts that are actually hard to perceive using some technologies like this. And again, oh yeah, there is one thing what I dislike is that the data engineers, it's outside of the loop, right? So there is something that is apparently checking everything that I have done. Come on, I mean, how is it possible? It's like, there is an application that will check that my web service is working fine without me providing input. This is nonsense, right? So basically, as a data engineer, I know what I want to check. I know what I want to make sure of, right? So I want to produce what visibility I need, the visibility I need, right? So giving the responsibility and the power to the people for me is important from the application perspective again. It also enables some decentralization of the monitoring. So instead of centralizing everything that is checking everything, right? You decentralize to the people who will embrace it, like testing, right? To be honest, everybody do a few tests, everybody logs, right? So you decentralize the monitoring instead of centralizing it. And second and last, I promised the last, but I have others, right? I've been doing data science, so Dean, you know it, right? So I've been doing data science heavily in my life, right? I'm a hater of anomaly detection and monitoring because it's super hard to do anomaly detection correctly. So first you have to have anomaly that are super precise, right? Because if you send twice or three times, an anomaly that is not an anomaly, all the different events you will be sending will actually be discarded, right? This is the alert fatigue. Second, I hope they will be there at some point, right? But they are not explainable. You cannot easily explain why an anomaly has been generated, right? That means that you leave to the people, the brain exercise to understand why the heck is this thing telling me that this is an issue, right? Instead of, okay, I have assumption about the data, I'm starting with this. And of course, I can be supported by anomaly detection, but please first check that the one I'm expecting is correct. So these are the different, actually, different best practices, not even actually Kensu versus Big I, right? It's really about the best practices, that needs to be embraced and the methodology in a way. I hope the answer makes sense.
I mean, I think, the big thing I took away from that is, you really sort of focused on contextualizing the data quality from, and that's a different perspective that I think is valuable. And then there's a lot of things that sort of derive off of that contextualization. I got to drop, guys, but thank you very much. It was a nice presentation.
Thanks a lot,
Sean,
Sean.
good seeing you again.
Yeah, see you guys. Bye.
And on this, I'm going to stop the recording.